Hello, Longhorns. Here is the review for test 5.1. This test covers exponential growth and decay, including calculating interest rates and also half-life. And so what you're going to be able to have to do on this test is solve for the final amount, the initial amount, the rate, the time, or the half-life if appropriate, depending on what the question is asking for. You are being given the formulas, although I would highly recommend that you memorize these formulas. You're going to need them in the future, and future teachers may expect you to have them memorized. So they're not difficult to memorize. I would recommend that you memorize them, even though they're being given to you on this test. All right, so let's begin with question 1. This problem is actually in two parts. In the first part, we have to find the rate of change. And then in the second part, we're going to use that rate of change to find out what the population is going to be in 2020. So I'm going to be using this simple exponential growth equation. And I'm beginning with the ending amount of 140,000. And we had a beginning amount of 125,600 people. And we don't know what the rate of growth is, but that's what we're trying to find out. But we know that that's what the growth rate, that's how much grew over the 12 years. So 12 is our exponent. Now we're going to solve for r. So I'm going to need to divide by 125,600. And then we're going to have to take the 12th root, or you can multiply the exponent with a rational exponent of 1/12. But since our calculators can do any kind of root we want, we can go ahead and just use the 12th root from our calculator. All right, solving for r, I divided by 125,600 on both sides, and I got 1.11465, and I took the 12th root of that, and what I got was 1.00909 equals 1 plus r, then subtract the 1. So I got that the rate was 0.00909, and so, which of course is 0.9%. So I'm going to use that rate in the next part to determine what the population is in 2020. So I simply use the same equation. I'm plugging the 0.00909 right here in for r, and to the 8th power this time, since I'm going from 2012 to 2020. And when I plug this calculation straight into my calculator, I get the answer 150,511 people. And that's it. So in these problems, you might have to solve for r, you might have to solve for t, you might have to solve for the initial amount, or you might have to just calculate the total. So it just depends on what the question is asking for. Now in question 2, we have Jackson bought a used Jeep for $20,000. The Jeep depreciates at a rate of 8.5% per year. How long until Jackson's Jeep is worth $8,500? So here we're solving for time. All right, so I've plugged all the components into my formula. 8,500 is what it ends up being. Let me get my pointer here. It ends up being this amount, 8,500. We started with 20,000, so that amount goes here. Our interest rate, or rate of depreciation, is 0.085. This is 8.5% per year. That means I need to convert this to a decimal. So this, to convert it to a decimal, is this, to the t, and now we're solving for t. And you know that anytime we solve for t, we're going to have to use a logarithm. But what I'm going to do is I'm going to isolate my rate to the t power first before I apply a log. All right, so I've divided both sides by 20,000, and I also went ahead and I took care of this calculation right here, the 1 minus 0.085, that's 0.915. And then the 8,500 divided by 20,000 is 0.025. Now I'm going to apply this log. My log base is going to be the base of my exponent. The base of my exponent is 0.915, so that's going to be the base for my log. So remember, you keep the base. The others change place. All right, so I did log base 0.915 of 0.025, and I got that t equals 41.5 years approximately. All right, let's move on to number 3. Okay, here's another problem where we have to solve for rate first, and then we're going to solve for time. So it's actually a two-part problem. So the first part, we're going to solve for rate. So we plug in what it was worth this year, which was $19,626.70. The initial amount, what it was worth, was $28,000. And then we have the 1 minus the r, which is part of our formula, to the 6th power, because that was 6 years. So we're going to solve for r. And we're going to do this the same way we did the problem number 1. Okay, so the first thing we had to do was solve for r. So we plugged in our equation, and then, of course, we divide both sides by 28,000. We get 0.70954 equals 1 minus r to the 6th power. Now, to get rid of this 6th power, we need to take the 6th root. So I take the 6th root of both sides, and I get the 6th root of 0.700954 equals 1 minus r. This is 0.9425 equals 1 minus r. Therefore, r equals a negative 0.0575, which is actually negative 5.75% if we wanted to put that as a percentage. Okay? Now, the other part is where we had to find time. So we took our r value that we found here, and we plugged it back into the equation. Now our beginning amount is this, 19,626.70, and we want to know how long it's going to take for it to get to 16,000. So this is going to be our initial amount this time. 1 minus the rate we found equals 16,000. That's the ending amount. We want to know how long it's going to take to depreciate to this amount. Divide both sides by 19,626.70. We get 1.9425 to the t power equals 0.815216. Then the next step is to take the log of both sides. Now remember, this is the base. So the log, this is the base, is 0.9425. This is not a 1. This is my dash line. Okay, so right here we have 0.9425 to the t power equals 0.815216. This is our base. So when we take the log, we keep the base. This is going to be our log base. And this is going to be our argument. So log base 0.9425 of 0.815216 ends up being approximately 3.45 years. All right, for this video's purpose, we're going to skip over some problems, but I will include them on the key that I'm going to post to Canvas. So just keep a lookout for that and also this video. I'm going to go ahead and move on, though, to question number 5. Problem number 5 is pretty straightforward. Luke, a future soccer star, signed an autograph picture of his favorite teacher, Mrs. Vaca. The picture, which is worth $10 now, is expected to increase its value by 20% each year. If the picture is worth $1,200 after 10 years, what is the actual rate of appreciation for every year? What is the appreciation rate for every year? All right, so first of all, we're going to take the $1,200 and divide by 10. After we've put this into our equation, so here's the future amount, $1,200, and here's the amount it is right now. It's worth $10. We're going to use a an increase rate, so 1 plus r to the 10th power, because that's 10 years. All right, so we've plugged everything into our formula. Now we're going to solve for r. Divide by 10, we get 120. Then we take the 10th root because it's 10 years. So we take the 10th root of 120, and we get 1.61405 equals 1 plus r. So we get r equals 0.61405, or that r is 61.4%. And that's it. We're going to skip to problem 7. All right, problem 7 is fairly basic. We take our principal amount of $10,000, and we're going to multiply that times 1 plus the interest rate, which is 8%. We're going to change that to a decimal, 0.08, that's a 0, 8, divided by 4 because it's quarterly. So quarterly is 4. That's going to be our compounding period. And we raise that to the 4 times 12. So I just put this straight into the calculator just like this, and I get $25,870.70. And that's all you have to do for that one. All right, in the next problem, Ryan wants to know how much he would have to invest in an account that pays 6% interest compounded monthly to have a balance of $30,000 at the end of 10 years. So basically all we're doing is solving for P. And so the first part right here should be just P times 1 plus 0.06 divided by 12 to the 12 times 10 equals 30,000. So all I'm doing is dividing the 30,000 by this part of the equation right here. So I divide by this part of the equation right here, just put it in the denominator, and I'm going to get the answer. So the answer is $16,489. So just make sure that your answer makes sense. If your amount is going to grow to 30,000, of course it needs to be less than 30,000 when you start. So your principal amount should be less than 30,000, and this is. So my answer makes sense, so I'm going to put a big old check mark there. Another way you can check is to plug it back in for P and do the calculation and make sure that you get 30,000. So you can actually plug this value back into P in your original equation and see if you get 30,000. That's the way you can check your answer. All right, for this problem, problem number 9, how long would Gavin have to leave his investment of $2,000 in an account that pays 8.5% interest compounded quarterly to have a balance of $15,000? All right, so we've taken our initial amount, which is $2,000, and we put it into our compounding equation, which is 1 plus the rate. Now you got to change that 8.5 to decimal, 0.085 divided by 4, since this is quarterly. This is compounded quarterly, so divided by 4 to the 4t, and we're solving for t. And we want it to grow to $15,000. So this is the initial setup. We're going to divide by 2,000 on both sides. I'm going to go ahead and convert this to one single number, and I get 1.02125, which is what this equals, to the 4t equals, and then 15,000 divided by 2,000 is 7.5. Now to solve for t, we need to take the log. So this is the base of our log. So that's going to be, since this is the base of our exponent, this is going to be the base for our log as well. So log base 1.02125 of 7.5 equals 4t. So remember, we keep the base, the others change place. So this comes here, this goes here. All right. So when I put this on my calculator, I get 95.8 equals 4t. Divide by 4, and I get that time is approximately 24 years. All right, in problem 10, John invests a sum of money in a retirement account with a fixed annual rate of 2.63% compounded continuously. Now this is your clue right here, this word right here, continuously, that you're going to be using the number E, the natural number E. If you have to compound continuously, you're going to use the natural number E, which means you're going to use this formula. Okay, so I'm plugging the values in that they give me for this problem. After 15 years, the balance reaches $1,912.41. What is the amount of the initial investment? So we're trying to find P. We're trying to find P this time. So we have P, base E, to the rate is 0.0263 times 15 years. And that should come to $1,912.41. So all I need to do is take this money and divide by the base E to this exponent, and that's it to get P. So what I get is, when I put this in my calculator, I get $1,289. And that's all you have to do to find P. Okay, for problem 12, if Charlie deposited $120,000, he won at the X Games doing the half pipe into an account that accrued interest compounded continuously, determine his interest rate if after 15 years the account balance was $195,389. So here we're solving for R. So our initial amount, $120,000, would be our P. We have a base E to the 15R. And we're solving for R. So we divide both sides by 120,000, and we get E to the 15R equals 1.62824. Now here we're going to have to take the natural log. Since this is a base E, the logarithm that goes with base E is the natural log. So this is a natural number, goes with the natural log. So we're going to use ln. So remember, we keep the base. In this case, we're keeping the base using ln. The others change place. So these two things are going to change place. So ln of 1.62824 equals 15R. We get that this ln of 1.62824 in the calculator gave us 0.4875. And then we divide by 15 to get R. So our interest rate ends up being 0.0325, or we could say 3.25%. So unless the problem specifically asks you for the type of rate, whether decimal or percentage, either one of these answers would be correct. All right, with problem number 14, we have Cole's brain is made up of the element magnesium-44, which is the hardest substance in the universe, thus making him the hardest-headed person on Earth. Magnesium-44 has a half-life of 6 days. If the mass of Cole's brain is 24 grams, how long will it take for his brain to decrease to 6 grams? I did not write this question. Cole, do not be angry with me. All right, so we have 24 grams, that's our initial amount. We have a half-life, so we're going to use 1/2 to the T over 6. This is the half-life is 6 days. So T over 6 would be the time over 6 days. So, and that equals 6 grams is what's left. So we're going to solve for T in this case. So we have 1/2 T divided by 6 equals 0.25. I got the 0.25 by dividing 6 by 24. So 6 divided by 24 is 0.25. I then take the log, okay, of 0.25. So our log base is going to be 1/2 since our base is 1/2. Since the base for this half-life is 1/2, our log base is going to be 1/2. So I used log 0.5 of 0.25 equals T over 6. So this in the calculator gave me 2. So T over 6 equals 2, therefore T equals 12. All right, for problem 15, we have that radon has a half-life of 3.8 days. After 7.6 days, a 6.5 remain. What was the mass of the original sample? So we're looking for the initial amount. This would be N sub 0 or A sub 0 or whatever the initial amount is always in this position. So we're going to call it N sub 0. And so we're solving for that. So all we have to do to solve for that is divide the 6.5, what remained after 7.6 days, by this half-life formula. So 6.5 divided by 1/2 to the 7.6 over 3.8 power would equal our initial amount. So when I put this in my calculator, right here, I get that the initial amount was 26 grams. I want you to practice putting this in your calculator to make sure that you know how to put this in. If you need to use extra parentheses down here in the denominator, don't be afraid to use the parentheses. All right, in problem 16, we want to know what is the half-life of this element after 820 seconds. One sample decays to 0.03125 grams. Okay, so that's what it's decaying to, but we need to find the half-life. We're looking for H. So we plug everything in to the formula, and we're going to solve for H. So here what I've done is I've taken this exponent, put it down here because I just need to take the log base 1/2 of this number here. So log base 0.5 of 0.03125 is going to give me this exponent, 820 divided by H. So I need that to find H. So I get this, when I put this in the calculator, it gives me the number 5. So 820 divided by H gives me 5. So H is 820 divided by 5. So H is 164 seconds. So its half-life is 164 seconds. All right, the last two problems I'm going to do are problem number 21 and 23. And we're going to focus on domain and range and the asymptotes of these and their inverses. So that is something that you're going to have to be able to do on the test. You're going to have to be able to find the inverse, and you're going to have to be able to determine the domains and ranges and the asymptotes. All right, I have a lot to explain here, so I'm going to go kind of fast. First of all, I'm taking my original equation, which is a log, and I am finding its inverse. So I'm looking for the inverse of this equation right here. So the first thing I'm going to do is switch my x and y, and then I'm going to solve for y. So I add 4 to both sides, I get x plus 4, and now I have this log base 2 of something. Now to get rid of this log base 2, I have to use a base of 2. So I'm raising everything to with a base of 2. So 2 to the x plus 4 equals, and when I raise this with a base of 2, this goes away, and I have 4y plus 3. So I have 2 to the x plus 4, and now I'm going to subtract the 3 and divide by 4. 2 to the x plus 4 minus 3 over 4 equals this inverse. All right, so here's my inverse equation. Here's my original equation. The other thing I need to do is find the domain and range for each. So I found the domain first of my original equation. I find that by taking this 4x plus 3 and setting it equal to 0. Because I know this can't be 0, it has to be greater than 0. So I find the domain, I solve for x, and I get that x equals a negative 3/4. So I know that my domain needs to be greater than a negative 3/4. So that's going to be my domain. My range for this function right here for logs is all real numbers, always all real numbers. The vertical asymptote, now logs have vertical asymptotes. Logs have vertical asymptotes. So the vertical asymptote of this log is x is equal to the same thing, the same number that it has to be greater than. So negative 3/4. All right, so for my inverse is going to have the opposite domain and range and the opposite, and instead of a vertical asymptote, it has a horizontal asymptote. So here I have the inverse for my domain. The domain for my inverse, is all real numbers. The range for my inverse is y is greater than negative 3/4, and my horizontal asymptote is that y is greater than negative 3/4. So you have to find the inverse, you have to know the domain and range, and you have to know which one has a vertical asymptote, which one has a horizontal asymptote, and what it equals. Okay, we're going to do exactly the same thing with question 23. Okay, we've done the same thing with question number 23. This one is a little tricky, so be careful of this right here. Because that x is negative. We have a little bit of an issue there that we need to discuss, but we're going to solve it the same way. So here we have x equals log base 5 of negative y plus 6 plus 3. I switched my x and y. Now I'm solving for y. So I subtract 3. I raise everything to a base of 5, so 5 to the x minus 3 equals a negative y plus 6. Then I solve for y, so subtract 6, and then divide by negative 1. So my inverse ends up being a negative 5 to the x minus 3 plus 6 is my inverse. Now if you're not sure if you got this right or not, or you're not sure about these negatives, go ahead and graph both of these together on your calculator and make sure that they are reflected across the y equals x line. And you can also graph in your y equals x line. Make sure it goes right through the middle of both of those. As long as they have an intersecting point on the y equals x line, then you know that, and they're reflecting across that line, you know that you got the right inverse. Okay, that's one way you can check that. All right, for the domain and range values, the domain for our original, I have to set this part right here less than or equal, greater than 0. So this needs to be greater than 0. Whatever I get inside this parenthesis needs to be greater than 0. So if I set that greater than 0, and this is where it gets kind of tricky because this x is negative. So when I subtract 6, I get negative x is greater than negative 6. But when I divide by the negative 1, my inequality flips over and I get x is less than 6. And you'll also see this on your graph if you graph this in your calculator. You'll see that the asymptote is at x equals 6. And it's real important to see that. So make sure you graph it and see that the asymptote is indeed at x equals 6. As long as that happens, then you know you've got it correct. Now, to find the inverse range and domain and asymptote, you're going to just switch these. So this one's range is this one's domain. So the domain of the inverse is all real numbers. The range of the inverse is y is less than 6. And the horizontal asymptote is y equals 6. So just remember, for domain and range on these two, you just switch them. That's it. So if you have any questions about this, please ask in class or come to tutorials and I'll help you with these. That concludes this review video for this test. I'm going to post the entire review answer key on Canvas as well, so you can take a look at any of the problems that you've done and make sure that you did them correctly. Also, please attend tutorials if you need help before the test. That's the best time to come in, is before the test, to get ready for the test. Good luck, Longhorns.